This presentation is on the indirect determination of yarn thickness, and to make the presentation we have with us Dr. Primentas, who is the Associate Professor in the Textile Engineering Department and Faculty of Applied Technology at the Technological Education Institute of Piraeus in Athens, Greece. Dr. Primentas basically teaches textile quality control, textile technology, in particular spinning, and specialized in quality control instrumentation.
Thank you, Mr. Chairman. Ladies and gentlemen, because the time I think is more or less very limited, I'll try to stick on my text and my notes rather than speaking by heart. This is much easier way for me in order not to make any mistake. Anyway, it was about 8 years ago when I was completing my PhD thesis at the University of Greece, when I had this problem of how can I measure the thickness or the diameter of yarns. It's very well known to everybody that there is no determination of yarn diameter when we're talking about span yarn diameter or thickness or bulkiness. Anyway, since that time, I left the whole subject, and recently I said that I have to do some textile work on that. Therefore, I could say that somehow I created or I formed a new method for indirect determination of yarn thickness / diameter. In the idealized yarn geometry, where the yarns have a cylindrical shape with a perfect circular cross-section, the measurement of their diameter could be made simply by observing the yarns or the woven fabric cross-section under a microscope. In practice, the twisted ribbon-like form of the yarns, the shape of their irregular surface where thick and thin laces appear, their hairiness effect, as well their compressed status in the woven fabric structure, prevent the determination of its thickness / diameter. To overcome the above difficulties, a method was developed to achieve a fast, indirect approximation of the yarn diameter using a fabric thickness device. This method could be considered effective since the fabric thickness depends on the interwoven yarn diameters. A proposed method for the indirect determination of yarn thickness became possible by using the following devices and accessories: a yarn wrapping frame, yarn appearance assessment blackboard device, a fabric thickness testing device, and an optical microscope. The yarn wrapping frame was similar to this special design pie-shaped frame, accompanied by two small plates for yarn holding. Its dimensions were such that it was possible to place it on existing commercial yarn and fabric testing devices. A light sponge material placed in the contact surface of the frame and the plates was used for better yarn holding. The blackboard device, the wrapping of the yarn samples on the unformation frame was achieved by using a yarn appearance blackboard device. The desired density threads per centimeter on the frame was set by its speed adjustment. In the fabric thickness device, using this experimental work, it was possible to adjust the load performed by a pressure foot on the yarn. The area of the pressure foot surface was 500 square millimeters, and the load range for this particular pressure foot area was varied from 1 to 2,000 gram force, which means 0.02 up to 40 kilopascal. And then we have a microscope for the direct determination of the yarn diameter, a conventional optical microscope of 40 times magnification. And then here is the method. First of all, we have wrapping of the yarn on the frame. using the Blackboard device. Direct determination of yarn thickness diameter using the microscope. And finally, determination of yarn thickness / diameter using the fabric thickness testing device. The frame was placed on the Blackboard device. After the preliminary tests, the appropriate yarn density, threads per centimeter, was set, and the final yarn wrapping took place. The frame with the wrapped yarn was removed from the device, and the two plates were placed on the frame to hold firmly the threads. The threads existed underneath the frame were cut and removed with much care. The frame with the wrapped yarn sample was ready for placement and examination in either the microscope or the fabric thickness device. Yarn thickness was considered the distance of the two sides of the yarn body as seen under the microscope, neglecting subjectively the zone of some protruding fibers. Diameter measurements were made in various places of the frame. The movement of the frame was made with great care to avoid any yarn or thread disturbance. In this case, yarn thickness diameter was considered the distance between the reference surface, where the yarns were laid, and the pressure foot that set on a load on them. The frame thickness was such to avoid any yarn disturbance in terms of horizontally formed angle, always lying on the reference surface. Moreover, the movement of the frame on the reference surface was made with much care as before. In this measurement, the stiffness degree of the protruding fiber during the yarn compression could not be done and thus could not be taken into account. At this point, I could say that there is a person in the audience who has done lots of work concerning compression of the yarns, so he may argue about it. We'll have to discuss it later. In the experimental work, the effect of the wrapped yarn density on the determination of yarn thickness / diameter was under investigation as the area of the pressure foot on the fabric thickness device was fixed. Thus, after experiments, it was decided to use 3 densities of 8, 10, and 15 threads per centimeter. 18 frames were prepared with carried cotton yarn samples of 6 various linear densities. Each prepared frame with a yarn sample was placed on the microscope. The diameter of 6 yarns for each of 5 different randomly chosen areas on the yarns on the frame was examined. The mean values of the total 30 readings are presented in this table. After the measurement of the yarn diameter with the means of the microscope, the frame with the same yarn sample was placed on the reference surfaces of the fabric thickness device. Successive tests were carried out by exercising load range from 0.1 up to 1 kilopascal with a step of 0.1 kilopascal on yarns of 6 different randomly chosen places on that frame. The mean values of thickness / diameter of the yarn with linear density 20 tex are presented in this figure. The correlation between the mean value of the yarn diameter measured by the microscope and the predicted value from the fabric thickness device could help the determination of the required load exercised on the yarns. For each yarn sample, the linear regression equations were formed according to the frame yarn density. To start with, an attempt was made to correlate the yarn linear density N with the diameter Y measured by the microscope. This equation was derived. So, for a 33.8 tex yarn, the reading from the microscope for its diameter would be 185 micrometers. For a 40 text yarn, the diameter of it would be about 243 micrometers. Also, the diameter for a 15 text yarn is about 153.7 micrometers. On the other hand, the correlation between yarn linear density and the load, X, exercised on the yarn in the fabric thickness device was expressed with the following derived linear regression equation. Thus, the load of 0.99 kilopascal exercised on the 23.8 text yarn would present a thickness reading of about 185 micrometers. Similarly, this load of 92 kilopascal on a 15 text yarn would present a thickness of 153.7 micrometers. It could be stated that this method for the determination of the so-called yarn thickness or diameter using the fabric thickness device seems very promising. As the conclusion, in this paper, an attempt to determine indirectly the yarn diameter by using a fabric thickness device was described. The results of a series of experiments supported the derivation of linear regression equations relating yarn linear density, yarn diameter, and load exercised on the yarn samples under examination on a fabric thickness device. The obtained readings from this device are not far from the readings of the same yarns obtained microscopically. Because this subject is still under broad investigation and further development, it is necessary to include three fundamental yarn parameters such as the twist, the hairiness, and the mass irregularity, as well as the compressibility in the next steps of the research in this field. All the above properties are interrelated and must be taken into account when we are dealing with yarn diameter. The knowledge of the yarn diameter will assist the more effective designing of accessories used in the knitting and weaving industry that come in contact with the yarns. Moreover, it will assist the formation of mathematical models for a better understanding of the yarn properties where the diameter plays a vital role. Thank you for your attention.
Thank you.